Imagine a lone traveler journeying for nearly half a century through the cold, dark emptiness between the stars. This is Voyager 1, a humble machine built in the 1970s carrying a golden record, a message in a bottle cast into the cosmic ocean. Its mission was to give us a postcard from Jupiter and Saturn, but it just kept going, fueled by curiosity and plutonium. Voyager 1 is now so far away that a command from Earth takes nearly a day to reach it, and its reply takes another day to return. Running on the power of a refrigerator light bulb, it continues to function, measure, and report. It crossed the heliopause in 2012, officially entering interstellar space, swimming in the medium between the stars. For years, Voyager reported a steady, thin hum of plasma, predictable, almost serene. The data confirmed our models of the local galactic neighborhood, but the universe always has a surprise. Just months ago, a new packet of data arrived at NASA's Jet Propulsion Laboratory. This data was different, impossible even, a signal that defied our understanding of the space Voyager is traveling through. It was as if a ship on a calm ocean suddenly reported hitting a solid, invisible wall. The scientists were stunned. The ghost in the machine had just seen something truly unexpected. Voyager's lonely vigil had uncovered a cosmic mystery that would change everything we thought we knew about our place in the galaxy. So, what was this impossible signal? Not aliens, but something just as profound. Voyager 1 detected a sudden, dramatic increase in the density of the plasma surrounding it, 50 times denser than before. It was as if Voyager had flown from the thin air at the top of Everest into the thick atmosphere of sea level instantly. This was a sharp, well-defined boundary, one moment in normal interstellar medium, the next in a region far denser and more energetic. According to our models, a structure like this shouldn't exist in the serene emptiness between stars. Interstellar space is supposed to be smooth, with features spanning light years, not razor-sharp boundaries. The signal was clear, verified, and by all accounts impossible. NASA's team checked and rechecked the data, suspecting a malfunction, but Voyager 1 was not broken. The probe had genuinely passed into a region of space unlike anything we had ever predicted. Our most distant explorer had stumbled upon a new cosmic mystery. The calm ocean of interstellar space had a secret, and Voyager 1 had just found it. This was a whisper from the void that screamed, "You don't know as much as you think you do." The scientific world was left both thrilled and deeply perplexed. Voyager's discovery was about to rewrite our understanding of the galaxy. Let's break down what Voyager 1 actually heard. Its plasma wave system listens for waves in plasma, the sea of charged particles that fills interstellar space. For years, this cosmic ringing gave us a steady low-density measurement, but now, the plasma was humming with a constant high-density signature, a new normal for Voyager's environment. The probe had entered a persistent state of high-density plasma, like moving from a quiet library into a bustling train station. The surprise is the scale and sharpness of this feature. Voyager crossed from low to high density in just days. This implies a razor-thin boundary in the interstellar medium. What could create such a distinct wall of plasma in the middle of nowhere? It's a genuine cosmic puzzle. Plasma denser and more contained than anything we've seen. It's as if there's an invisible force field holding this plasma cloud together. This anomaly challenges our fundamental understanding of how gas and plasma behave on a galactic scale. Voyager 1 didn't just find something new, it found something that questions the very rules we thought governed the space between stars. The emptiness, it turned out, wasn't so empty after all. To appreciate this discovery, consider Voyager 1's journey. Launched in 1977, it gave us our first close-up images of Jupiter and Saturn, then kept going. After its planetary mission, it became the Voyager Interstellar mission, aiming for the edge of the solar system and beyond. In 1990, it captured the famous pale blue dot image of Earth. Today, Voyager 1 is over 15 billion miles from Earth, the most distant human-made object. Designed to last 5 years, it's still sending data nearly 48 years later. Its power is dwindling, forcing engineers to shut down non-essential systems. Every day is a gift, another chance to learn from the great beyond before Voyager 1 falls silent. This long, patient journey put it in the right place at the right time for this impossible discovery. Voyager's endurance is a marvel of engineering and human curiosity. Its epic tale is far from over. Picture our solar system as a giant bubble, the heliosphere, carved out by the solar wind. Far from Earth, this wind slows as it pushes against the interstellar medium, creating a turbulent boundary called the heliosheath. Voyager 1 crossed into this shoreline in 2004, then, in 2012, detected a sharp drop in solar particles and a surge in galactic cosmic rays. This was the moment it left the solar system, entering interstellar space, a monumental achievement. For more than a decade, Voyager reported calm, thin, uniform plasma, confirming our models. This long period of calm made the recent discovery of a dense plasma wall so shocking. It's not in the turbulent heliosheath, but out in the quiet zone, a place that was supposed to be simple and predictable. The universe, it seems, is always more complex than our models allow. Voyager's crossing into interstellar space was just the beginning. Now it's revealing secrets we never imagined. The cosmic shoreline is far stranger than we thought. When Voyager 1's discovery broke, the scientific community was electrified. A clean, undeniable piece of data that breaks all the existing theories is what scientists live for. The initial reaction was skepticism, maybe a glitch, maybe a flaw. But the signal held firm. It was real. Dr. Ed Stone, Voyager's longtime project scientist, said, "In over 50 years I've never seen anything like this." The sharpness of the boundary is the key puzzle. How can plasma 50 times denser than its surroundings have such a well-defined edge? It's like finding a puddle of water that holds a perfect cube shape. Theorists are scrambling for explanations, running simulations, and searching for clues. We can't see the feature directly, but we can look for subtle changes in starlight passing through this dense region. One anomalous reading from a half-century-old probe has energized the entire field of interstellar physics. It's a beautiful example of how one data point can spark a scientific revolution. Voyager's signal is rewriting the rules. What could this mysterious plasma wall be? Scientists are exploring possibilities from the mundane to the exotic. One theory? Voyager encountered the edge of a cold molecular cloud, a star nursery. But the sharp edge doesn't fit. Another? A bow shock from a nearby undetected star. Plausible, but would require a star to be surprisingly close. Some propose it's the remnant of an ancient supernova, hot, dense material from a long-ago explosion. But again, the sharpness is a problem. The most speculative ideas suggest new types of cosmic structures, or even the influence of dark matter clumping in unexpected ways. When data breaks the rules, we have to question the rules themselves. Whatever the answer, this discovery will force us to rewrite the textbooks on the interstellar medium. Voyager's find is a cosmic riddle. The search for answers has just begun. This discovery does more than challenge science, it changes our perspective. The universe is not a static backdrop, it's dynamic, mysterious, and full of surprises. Probes like Voyager show us that space is an environment, not just scenery. We are part of this cosmic ecosystem, only beginning to understand our neighborhood. Direct exploration is irreplaceable. No telescope or model can substitute for being there. Voyager's data revealed a gap in our knowledge that only a physical probe could find. Through its instruments, we are all touching a piece of the galaxy undisturbed for eons. The data it sends back is a tangible link between our world and the vast universe. It reminds us we are not isolated but active participants in a much larger story. Space exploration unites us, challenges us, and feeds our curiosity. Voyager's discovery is a mirror reflecting our own potential for wonder and understanding. Why does this matter? Because exploration is in our DNA. From our earliest days, curiosity has driven us to cross new frontiers. Voyager 1 embodies this spirit, a robotic extension of our senses, sent to touch the unknown. Its mission spans generations, connecting past, present, and future explorers. The universe doesn't give up its secrets easily. It makes us work for them. This new mystery is a gift, a new chapter in our book of knowledge. There are still dragons on the map, still discoveries waiting in our own cosmic backyard. We must keep building the next Voyagers, pushing the boundaries. As Voyager 1 continues its silent journey, it carries our hopes and dreams. Its story is our story, a testament to our unyielding spirit of inquiry. The cosmos beckons, and we must answer the call. To explore is human, and our future is written in the stars.